And then the worksheet they did on Wednesday
is to find x. Remember, x is the angle. So we're really finding the angle. So I'm going to make a little XY axis here. We need to think about the sine. And the sine being equal to 1/2. Remember, sine is y. So my y value is 1/2. If the y value is 1/2, what's the x value? √3/2. Okay. So y is positive 1/2 in the first quadrant. And it's positive 1/2 in the second quadrant. Y is positive in the upper quadrants because anything below the x-axis, it's negative. So our goal is to find the angle when the sine is 1/2, or when my ordered pair is √3/2 and 1/2, and negative √3/2 and 1/2. So this is where it gets challenging because you have to now pull back that unit circle. And I will say that in AP Calc, those kids pull that unit circle again and again and again back into calculus. So like it doesn't go away just because you learn it. So that unit circle, they had a unit circle test like 2 or 3 weeks ago. So Jack, what angle has an ordered pair of √3/2 and 1/2 on the unit circle? So pi/6, that's this angle right here. And then how about the angle in the third quadrant? 5 pi/6. This is the answer to part A. Those are specific angles. They're from 0 to 2 pi. You will have 2 of them because the sine is positive in 2 quadrants. So we solve for the sine, and then we're finding the angle when the sine is 1/2. Now it says to write it in general form. General form will get me that angle every single time I spin around the unit circle. So to write general form, you take the angle, pi/6. And if I want to find that same angle by spinning all the way around the unit circle, what would I do to pi/6 to find that same angle, but rotate one full spin around the unit circle? Jenny, do you know what I would add to it? You would add 2 pi. Well, I'm going to place next to that 2 pi an n. And that n represents the number of times I could spin around the unit circle. I could go 1 time, I could go 2, I could go 7, I could go 27. Anytime I go around the unit circle, I'm going to hit that angle again and again and again and again. So now I have a general form. I can place a minus with that as well, because I could go in the opposite direction. Anytime it's negative, I'm then rotating clockwise instead of counterclockwise. So general form, my original angle plus or minus, and then 2 pi times n, the number of times you want to spin around. So I could say, like, find the first 5 angles, and then I could use this equation and just place a 1 in for 1 time around, 2 in for 2 times around, and so on. We have 2 angle answers, 2 specific answers. So that means I have 2 general solutions, 1 for each angle. So Caden said the second angle was 5 pi/6. And then you're still adding 2 pi n, or subtracting 2 pi n to get to the angle in the second quadrant. So you find the specific answers. To write it in general form, you're using those specific answers. So part of the homework just wants the general form, but really you need the actual angles in order to write the general form. But some of the homework just says write the angle answers, so you wouldn't have to do this part. Questions? So we just solved the trig function, trig equation. Any questions? All right, so let's look at number 2. I said I started off easy. Number 2 looks totally different. We have the cotangent times the cosine squared equals 2 times the cotangent. So think about solving an equation. This one now has 2 different trig functions in it. So we need to try something to solve this equation. And I can't isolate one of those because there are 2 different functions in it. So what do you think we could do, Peter? So it would be nice if we could divide a cotangent out. And we are going to kind of do that. But if you divide out a function, then you lose the answers associated with that function. So we're not going to divide it out totally, but we are going to divide it in some way. So algebraically, Jenny, what's another way we could try and divide? So yes, we're going to do exactly that, except we're going to keep it as cotangent. So I'm going to keep the cotangent in there, but we are going to be pulling something out. We're going to take this cotangent to be on the other side, and we're going to set it equal to 0. So we're going to try and set this equal to 0. So we have cotangent times cosine. And then you're subtracting that whole cotangent to the other side. So David said we're going to try and divide it out. And Jenny said, let's try and pull it out. What could I take out of the left side now? Joe, what could I take out of that left side? Yeah, we can factor out a cotangent. So really factoring out is dividing, but it's keeping it in the equation. You're not losing that function or losing the answers. Joe, when you factor it out, what do you have left? When you factor and solve, your equation always must be equal to 0. That's the 0 product property. You can only solve for x when the equation is equal to 0. Once it's a product, you're allowed to individually separate them and solve for each piece. Remember, if this said x times x minus 2, I would now take the x, set it equal to 0. I'd take the x minus 2 and set it equal to 0. So we're going to take the cotangent and set it equal to 0. And then we're going to take the cosine squared and set it equal to 0. That's how factoring works. Factoring is a way to solve when it's equal to 0. Once it's factored, split them apart and individually solve for each, in this case, function. So let's get that cosine squared by itself first. Jack, if I took the 2 to the other side, what would you do next to solve for cosine squared? Oh, let's square root both sides. Anytime you square root something that was squared, you have a plus and minus answer. All right, so now I have cosine equaling plus or minus root 2. Cotangent equals 0. Both functions are now by themselves. So now you need to pull the unit circle in, and we have to actually find the angle. So we've done the solving part. We got the cotangent and the cosine by itself, but we want to find the angle. Cotangent is the reciprocal of tangent. So tangent is y over x. That means cotangent is x over y. So what must x be in order for the cotangent to be 0? 0. So our ordered pair has to be 0, 1. So on the unit circle, when is the x 0? Well, it's 0 on the y-axis at the top. and it's 0 on the y-axis at the bottom. That would be my ordered pairs, 0, 1, and 0, -1. So Jeremy, what would those two angle values be? Yeah, pi over 2 and 3 pi over 2. So Peter, I'm not picking on you, but if we divided out cotangent, I would be missing 2 of my solutions. So they wouldn't be there, and then I wouldn't have answers to solve for. So 2 of my answers are pi over 2 and 3 pi over 2. Now let's talk about cosine. Remember, cosine is x on the unit circle. We have cosine being equal to positive or negative root 2. When is x equal to positive root 2 or negative root 2 on the unit circle? Is it? No. It's the square root of 2 over 2, but not just the square root of 2. Does anybody remember the range of cosine? What's the largest value for cosine or the smallest value of cosine? Think about the graph. How high did the graph go? How low did the graph go? What were the values for cosine? Hayden, do you remember? 1. Cosine goes from -1 to 1. That's what my values would have to be. Hayden, what's wrong with the square root of 2? It's bigger than 1. So that means this part of the function is undefined because it's bigger than 1. So the fact that the cosine is equal to positive or negative root 2 is not an answer. There's never an x value because there's never an angle on the circle that would be bigger than 1 or smaller than -1. It's always between -1 and +1. So this part here is really not part of our solution. Remember the word extraneous solution? That one's extraneous. Questions. So for part A, our only angles are pi over 2 and 3 pi over 2. Part B says write the solution in general form. So my first angle is pi over 2. I want you to think about this. If you look at pi over 2 and you look at 3 pi over 2, what could I add to pi over 2 to get to 3 pi over 2? Peter? I could add pi. The period of tangent and cotangent is only pi. So if I have an angle at 3 pi over 2 and I add pi, pi over 2 and add pi, I get 3 pi over 2. If I add another pi, I'm back at the top. And if I just keep adding pi, I will just keep hitting both of those angles. You only need one general equation when it's cotangent, because I can create 3 pi over 2 or find 3 pi over 2 just by taking pi over 2 and adding pi. That happens with tangent because the angles are 90 degrees across, 180 degrees across from each other, and because the period of tangent and cotangent is pi. So one general equation instead of 2 like the previous problem. Questions. That one was totally different. The first one was pretty straightforward. Anybody at home have questions? All right. So trying to look at a few more examples. Just like the identities, every problem is slightly different. So let's look at example 3. The goal is to show you different methods to use to try and solve the equation. This one says solve the equation in the interval of 0 to 2 pi. So that means I don't need a general form. I just need to find the angles. We have 2 sine squared minus sine minus 1. So think about the form that this is written in. Cole, what do you think? We are going to factor this AC grouping. It looks exactly like ax squared plus bx plus c. So Cole, we have a -2. We would be using so 2 sine squared minus 2 sine plus sine minus 1. Just as if it were x squared, but it's sine squared. Factor out a 2 sine, and then I have sine minus 1. The other pair, they're only divisible by a 1. So I'm still going to place that 1 there so that I remind myself I have another term. The GCF in that second pair is just a 1. So 2 sine x plus 1, and then sine x minus 1. Zero product property. When you have a product and they're set equal to 0, you're allowed to individually solve for both quantities. So I can solve for both of these and say the sine is equal to -1. Or the sine is equal to -1. So see if you can find an angle. Oh yeah, thanks, Cole. Good catch. Thank you, appreciate it. Positive one, because when I added to the other side, it should be positive, thanks. So try and think of an angle or multiple angles when the sine is equal to -1/2. And then on the other side, we want to find when the sine is equal to +1. Remember, you're finding angles, and if it helps to draw a little diagram, sine is y. Just remember that sine is y. The ordered pair would be 0, 1. Sine is -1/2 in the third quadrant and -1/2 in the fourth quadrant. So y is negative down below the x-axis, positive up above. Jeremy, what family of angles would we be working with if the sine is 1/2? Yeah, so we're looking at the pi/6 angles. So that's our family. So I want that pi/6 angle in the third quadrant, and then I want that pi/6 angle in the fourth quadrant. Gianna, do you know what pi/6 angle would be in the third quadrant? That would be the second. So add 11 pi/6 is one of them. That would be the fourth quadrant. Does anybody know what the angle is in the third quadrant? Peter? 7 pi/6. So remember, there's 6 pieces of pi on the top, 6 pieces of pi on the bottom. So if I go through 6 pieces, this is my 7th piece of the pi out of 6. So those will be the angles when the sine is equal to -1/2. 7 pi/6, 11 pi/6. Evan, when is the sine equal to 1? Or what value would my angle be 0, 1? At 90 degrees, and 90 degrees is pi/2. So my solutions, we have 7 pi over 6, 11 pi over 6, and then pi over 2. We have 3 angle solutions. All of them are solutions. Each and every one. Questions? So the first equation, we just got sine by itself. The second equation, we had to set it equal to 0, and then we factored and solved for each factor. This one was equal to 0, so we could just factor it using AC grouping. Try and look at number 4. And using the information that we've just gone over, see if you can solve sine plus root 2 equals negative sine. So think about what you would need to do to solve this. It says write the solution in general form, but again, we kind of need the angles, the specific angles, to write it in general form. So think algebraically, what would you do to try and solve this equation? I don't know how you rate on that with that such like slant. I'm not very good. That's such a, I have to prop it the other way. Jack, what are you noticing here? Yeah, we can take the negative sign to the other side. We have a sine and a root 2. We can add the sign. Parker, what do you notice on the left side? What do you get? 2 sine x. What do you think you do next, Parker? Excellent. I'm going to do it in the same step since you said it together. So he said take root 2 to the other side and divide by 2. So add sine to the other side. They're actually like terms. Sine x, I got 2 of them. And then isolate the sine. So now we have the sine by itself. That's the algebra part. Now we have to do the trig part. So you are doing algebra, but then we still have trig. So this one's sine again. Remember, sine is y. We just said y was negative in the 3rd and the 4th quadrant. So in the 4th quadrant, x is positive. In the 3rd quadrant, both x and y are negative. So angles that have the ordered pair, root 2 over 2, root 2 over 2. Kaden, what family of angles are we dealing with here? Pi over 4. Yeah, so we're thinking pi over 4. So Kaden, in the 3rd quadrant, it would be pi over 4. And in the 4th quadrant, it would be, nice job. Again, remember, really, we have 4 pieces of pi on the top. So here's my 4 pieces, 5 pi over 4, 6, 7 pi over 4. So those are my answers. They're specific angles, but it said to write it in general form. So to write general form, when it's sine, I just need to add 2 pi times n. Because if I want to go all the way around the circle and come back to that angle, I need to add 2 pi. From 7 pi over 4, again, I need to add 2 pi and then n. So sine's period is 2 pi. To get back to that original angle, I need to go all the way around the circle. Questions? So there's one final equation on here dealing with tangent, lovely tangent. 3 tangent squared minus 1 is equal to 0. Find the specific solutions and then the solutions in general form. Leah, what do you think you'd do first? What do you think you'd do with that -1? Move it to the other side. Yeah, we just have a tangent squared. So let's take that -1 to the other side. And then Leah, what else do you think you'd do? Divide by 3. So if I have tangent squared, just like I have x squared, we would take the square root of both sides. What is the square root of 1/3? Peter? Root 3 over 3. So you're taking the square root of 1, you're taking the square root of 3. The square root of 1 is 1. So I would really have 1 over root 3. And when you rationalize that, you get root 3 over 3. What goes in front of root 3 over 3? Plus or minus, because we took a square root. Tangent's a little trickier because tangent is y over x. So we need to think of those ordered pairs. How would I get a root 3 over 3 when I'm taking y over x? This is my pi over 3 angle. Here's my pi over 6 angle. So those are our two angles. If I have y over x, which one of those ordered pairs would make root 3 over 3? Yeah, it's going to be a pi over 6 angle because 1/2 over root 3 over 2. My 2's cancel and I end up with 1 over root 3, which is what we had before we rationalized. So my angle has to be pi over 6. All right, let's think about tangent. Oops, that's really crooked. So tangent is plus or minus. Hayden, where's tangent positive? Right, first and third is where tangent is positive. So I would have root 3 over 2 and positive 1/2, or negative root 3 over 2 and negative 1/2. Hayden, where is tangent negative? In the second and the fourth. Because it's a plus and a minus, I actually have 4 answers. 2 of them are in first and third. The other 2 are in 1 or 2 and 4. Peter said it deals with pi over 6. So I would have an angle at pi over 6 and an angle at 7 pi over 6. That would be my positive angles in the first and the third quadrant. My negative angle, I'm not negative angle, but my negative tangent would be in the second quadrant. Well, that's 5 pi over 6. And the fourth quadrant, which is 11 pi over 6. So these 4 answers would represent the 2 positive answers and the 2 negative answers. 2 times when it's tangent positive, the 2 times when tangent is negative. The last part of this says, write the solution in general form. So this would be part A's answer. That's my specific solutions. Part B, we need to write it in general form, and this is tangent. So if you notice, my pi over 6 angle and my 7 pi over 6 angle are directly across from each other. They're diagonal from each other. So when I go to write it in general form, you don't need to add 2 pi. I just need to add pi to my first angle. That's supposed to be an n. Because then once I add pi, I can go directly to that second angle. My 5 pi over 6 and 11 pi over 6 are a different pair of angles. So I would have 5 pi over 6 and then plus pi. So this picks up the angles when it's positive, and that grabs the angles when it's negative. Questions? So the group of problems that you have for homework tonight should be very similar to those problems we just went over, and it's 29 to 43 off, which I think ends up being like what, 8 problems? Yeah. Try and think of factoring or isolating. Those would be the 2 steps, they're process methods that we've talked about today. Questions? Not so bad for a Friday. All right. Everybody at home, have a fantastic weekend.